Good morning, ladies and gentlemen. Today is Saturday, April 10th. It is a beautiful day here in North Carolina, and we have a lot of interesting things to talk about today. So I'm glad you are here to join me, and let's just jump right in. Of course, join me in the chat, and as always, the source code for everything we will be doing is available on GitHub, which will lead me into the first thing that I want to talk about today. I just want to make sure that I have been clear about what exactly is going on with the channel and what we are trying to accomplish here. So this is primarily a channel of me making something and making many different things. And while I am making things, I am going to have to be learning things. So as I learn things, I make videos about what I learn so that I have some sort of educational content to the channel. And so as we are building something together, we are also able to create an educational platform where we can learn about programming more together. And through GitHub, which is where the source code for all of this is available, I have found a way to streamline a lot of this process. So some of you guys have been actually contributing code to these projects, which is absolutely fantastic. I love that you guys are actually contributing to the projects. That was kind of the whole point, and I'm really, really excited that you guys are wanting to participate in this with me. But I've found on GitHub that there are some additional features that I have not been taking advantage of that I want to start taking advantage of. So, for example, projects. This is libeom, so this is my library of tools, and I have opened different projects for the different sections of the library. And within them, I can create different issues or timelines or things that need to be done. So, for example, if we look at data structures here, we can see that we have these columns. And this is a Kanban style of development organization. If you haven't heard of that, it's a common methodology for professional environments to organize projects. And basically, you organize tasks into cards, and then you move them into different categories as you complete them. So GitHub has a projects tab that allows you to do exactly that within GitHub, right next to your source code. So here we have what is called an issue. And anybody can open up an issue. So you guys are welcome to look at the code here and open an issue in GitHub. In fact, a friend Camel Coder, who is on the Discord server with us, I lost a connection to something. That's okay. We are going to... I lost a connection. I'm sorry, you guys are seeing the back end of the stream, but I lost connection to my other screen, so I need to make sure it's still running. We are still good to go. Sorry about that. Technical issue. I may try and fix it in a little bit. Anyway, so on GitHub here, Camel Coder has opened up an issue on my project. And this was related to a code challenge that I presented for sorting and searching a linked list. So Camel Coder has created a algorithm for a merge sort for my linked list, which is perfect. It's exactly what I was asking for. And so on this person's own, I don't know he or she, but on Camel Coder's own, they created this issue, linked it to this particular project, and were able to submit code for me to add to the project. And their code is fantastic. I love their code. There's just one small change I want to make to it, and it's just that it takes as an argument somewhere in here. Yeah, the sorting function takes a pointer to a node, and I want the users to interact with the list rather than the node itself. So I can come in and ask for a change to be made to it. So simply, I would like an interface made for this algorithm that takes as an argument the linked list rather than the node object. And then once that change is made, then I can come back over here to the project and over here in data structures, and I can move this into the next category. We're not actually going to do that yet, but you can see how this allows you to sort of organize things, and it's going to allow us to work together in a better way. And also, in order to work together in a better way, I need to be able to see your comments, so I am going to fix that screen. And I don't know, did it run out of battery? I think it may have run out of battery. So we are going to do an emergency stream service here on the iPad, and I am just going to plug it in and let it charge. Bit awkward. Sorry about that. I thought it was fully charged. So let's reorganize these so that I can actually check in with the chat and be a good host here. Good. Okay. So we have GitHub to help us sort of organize the process of these projects. And let's talk about the repositories themselves and what we are working on here. Suddenly I have a bunch of activity. We have libeom, and this is the library of tools that we are working on. This is the data structures, the sorting algorithms, these network objects that we're creating, and they're designed to be useful in kind of any circumstance. So any project that we're working on where we would need a linked list, this is where we would get it. We have made this linked list, we know this linked list, and this is the one we will use. The sketchbook is for experiments. So throughout the week, I am often trying to experiment with the next thing that will be added to the library. And so I will do those experiments here in the sketchbook. And I will also open up issues and projects here as well. So these two repositories are sort of the main things going on right now. But we are at a point where that is about to change. So again, unfortunately, I've lost my other screen here, so I have to show you my notes. Let me try and turn it back on. There we go. All right. You'll have to excuse me while I reset up the screen. I apologize for that. Not very professional, is it? Not what I wanted. Okay, and did these move over by themselves? They seem to have, but I need to move this. Excellent. Okay, now I can see you guys again. Great. So, I apologize. That has thrown me off a bit. So we have looked at GitHub, and I've shown you how we are going to use it to organize projects. And I've shown you libeom, and the sketchbook. But we are about to start looking at a project that is going to kind of splinter off of libeom. So it has started in there, but we can't really keep it there anymore. It's sort of becoming its own thing at this point. So let's take a look at what we've been working on this week. So I've created this structure. This is for our blockchain project. We've been building this peer-to-peer network over here, this peer-to-peer object. And it takes a client function and a server function. We have an example of this here in the test file. This is all available on GitHub. So libeom, and make sure you switch to the working branch. And we have this test file here. This is where we define our server function and our client function. We then pass those into the peer-to-peer constructor, and then we just run it. And it's going to basically enter these infinite loops where it is doing whatever we have told it to do. And in our case, we're trying to build a blockchain. Now, last week, we talked about how a blockchain works in a broad sense. So we looked at how to build one in Python. And we did this so that we understood how a blockchain works. And now we are actually implementing it at a deeper level and sort of looking at some of the problems that we face when we are trying to do that. So what we have are these objects here. And this is specifically trying to address the contiguous memory problem. And how are we going to send something across the network? So looking at how these functions work, essentially the client function is going to send something to the server. The server is going to read in whatever it has received, and then we are going to do whatever we do with it. And we are going to be sending raw binary data. And in order for us to be able to identify this data in some way on the network, we need a network protocol. So essentially, we are going to attach a certain number of bytes to the beginning of whatever we're trying to send, and that is going to contain the information regarding whatever we need for the network itself, if that makes sense. So the block headers are that information. And so here I have some fields, and these fields are, for now, more or less arbitrary. I just have them in as an example. Some of them I do know we're going to need, like the nonce and the previous hash, and some of them are, for now, just examples. We can really put whatever fields we want in here. The important characteristic of this structure is that it is of a predictable size. It is 164 bytes. Now, that's not entirely true. We will talk more about why in a moment, but for now, let's just say that this is 164 bytes. Since we know it is 164 bytes, we then create a second object, and this is our block object. So the block contains an instance of a block headers object and 1 byte, a single unsigned character for data. And you don't actually use this data as a single byte unsigned character. If we look at how this is actually implemented, where we create the block right here, we allocate a certain size to it. And what do we want to allocate? So our data in this instance, where is our data? String length request. Our request is here. Okay. So in the client function, we have entered this infinite loop. And in the infinite loop, we set up some variables. And the important one is this empty string, request. We clear out request, and then we take some input from the user. And once we get that input, we are going to create the headers for our block, so that headers structure. So I create some dummy information for all of the fields in there. And what is important is when I get to here, and I am actually creating the block that these headers are associated with, I allocate memory that is enough for both the block headers and that single byte for the block, and no, I'm sorry, we allocate space that is for the size of the block headers and the data that we have. So whatever data we are trying to send, so whatever the client sends us, we are allocating that space for it. And then what we do is copy into this void pointer first the headers that we created for it, and then the actual data. And we use the address of the block. I don't think this code is actually doing that here, which is a bit of a problem, but that's okay. So we use this as a memory address. So we call the address of data. And this gives us access to all of the things that come after data in memory. Okay, so if we look at this in an implementation, so here in the server function, we accept our client, and then we read in their request, and we are going to allocate space for a block. And let's see, when we want to actually print the data, so right here, we have gotten the data from the client, and this is a raw block. What we can do is cast that raw block as, or that raw binary data as a block. And we know the size of the headers, so we can access all of those fields pretty easily. We can say block.headers.previous or block.headers.nonce, and we can access those really easily just by casting that data and essentially laying our struct over those first bytes, 164 bytes. And then when we want the actual data that's in there, in this case a string, we say in our formatting string here, this %s, that we are going to be receiving a string, and then we use the address of block data. And even though this is a single byte, the subsequent byte is not a null terminal character. It is more data, in this case, more of the string. So it will, in fact, just continue reading the string. So if I actually run this, it takes a second to run the first time. But in a moment here, we will get a message. Server running. So if I send hello world, we can see all of the data about the block is received by the server, and it prints out the data itself because it accessed the address of that data rather than trying to treat it as a unsigned character. And the thing I want to stress here that's really important is that a lot of the design features that I am learning about here are features of the fact that in C, you can really think of everything as being bytes rather than being data types. So when I create this object and I create this unsigned character field data, I am just thinking of this not as an unsigned character. That's more or less arbitrary. I just want a byte. So this isn't an unsigned character to me. This is just a single byte in memory. And I know that if I just allocate more space after it and copy into all of those addresses the data that I want, then this is fine. I can just use the address of this particular byte to signify the beginning of the rest of my data. This all hinges, though, on the fact that I know the size of my block headers, because since I can predict the size of my block headers, the block headers tell me what the size of the rest of this data is, so I know where this actually ends. So I really need these block headers. Plus, the fact that we're doing this on a peer-to-peer network, we need some way to signify to each other that we are creating valid objects and sending valid things. So we need to know the size of this object, and you can see here I have laid out where this falls in memory, how many bytes each of these take up, but this isn't exactly correct. And the reason has to do with the way your processor is going to compile this and run it. And it has to do with the way that your processor is going to actually read things from memory once it has stored them. And I can actually demonstrate this well with a photo editing app called Photopea. I'm going to create a new project here. And we are going to zoom way in. And we can see we have a bunch of squares here. I'm going to create a thing in black. Let's leave that over here. And let's grab pencil. And make it 1. Okay. So we can think of all of these little squares as memory addresses. And what we would say is if we imagine that I create a data structure, and where'd my mouse go? My mouse disappear? It does this sometimes, and I don't know how to get it back other than to turn off my screen and turn it back on. I don't know what this is going to do to the stream, though. We're having some technical problems this week. It's a good thing there's only one person watching right now. So, okay. So I'm going to have to I'm going to turn off the screen and turn it back on. Let us all hope that nothing goes wrong. If something does go wrong, I will be right back. Pray with me. We still good? It seems we're still good. Okay. I'm going to move on as if we are still good, and if we are not, we'll find out. So, we can think of all of these as memory addresses, right? And if I create something, let's imagine a struct. I lost the mouse again. Sorry about that. So if I create a struct that looks like this, we're just going to create it down here. I'm not going to keep it, though. So let's say I create a struct, and let's say I give it these fields. Let's say I give it a character A, a character B, and an int c. Okay, so this struct has 3 fields. The first field is 1 byte, second field is 1 byte, and the third field is 4 bytes. So if we look at this in memory, we can say that the red, that's our first character. I guess I have to hit OK there first. There we go. The technical problems this week, I don't know. So the red is our first character. We could say the green is our second character. Ah, I see what's going on here. Okay, the green is our second character. And then we'll say blue is our int. Okay, so 1 byte, 1 byte, 4 bytes. But this is not actually how your processor is going to store this struct. And the reason has to do with what is called padding. So if I use black, your processor, depending on whether you have a 64 or 32-bit, hello, Mr. Gamer. I have no experience in blockchain, but I understand what you are doing. Great. I am glad that I am being clear enough that you can understand what I'm talking about. Anyway, your CPU is not actually going to read this as, or save this as this structure, because it can't read it as this structure. It depends on what is called your word size. And that is the number of bytes your CPU is going to read in a single clock cycle. For a 32-bit CPU, 32 bits is 4 bytes. So your word size is going to be 4. So if we put in some black squares, that's going to be 1 word. And then we have 4 white squares for 1 word. That's going to be the next word. And so here we have 1, 2, 3, 4, 5 different words. And what you can see is that this int falls where it would be cut in half by the word. And your CPU wants to read this all in at once. So what it's going to do, instead of storing it using 1, 2, 3, 4, 5, 6 bytes, it's going to store it using 8 bytes. So it will use 1 CPU cycle to read in that word and get those 2 fields, and then it will use 1 CPU cycle to read in that word to get that field. Okay, so this is great in terms of being more efficient with our memory or our CPU cycles. So this is faster, because if we did it the other way, where we had it cut in half by the word, we would take 2 CPU cycles to read that 1 data field. And that's an inefficient way of doing it in terms of these CPU cycles. But it's inefficient in terms of memory. You can see that this struct takes up 2 more bytes of memory that are unnecessary. These are just empty bytes. Okay, so it's making that trade-off. And the problem is that in a 32-bit architecture, you have a word size of 4 bytes. But in a 64-bit architecture, so 64 bits, that is 8 bytes. So our word size is going to be that. And then we'll have that. So that is our word size. Sorry, Aiden, you're on the stream now, apparently. Got to get you off that. Turned on Do Not Disturb. I don't know why it's still sending me things. Sorry. This has been a very unprofessional stream, hasn't it? I'm doing my best. Anyway, all right, so our word size in a 64-bit architecture, my machine here, this MacBook, is a 64-bit machine. So its word size can actually read in all of these bytes at once. So it will, in fact, store them in contiguous memory. So if we do our red here, green, nope, and blue. So it will actually store our struct in contiguous memory like this in a 64-bit machine. And The problem arises when this is being sent between nodes that need things to be the same. So remember, we are trying to take our headers struct and just lay it on top of some raw binary data that we are getting. But if I create it on a 32-bit machine, then what you try to lay over it on a 64-bit machine won't fit because of these word sizes. So what we need to do is tell the compiler to use a particular method and use it across the board so that everybody is using exactly the same thing. Fortunately, in C, this is rather easy to do. So I'm going to delete this. And what we can do is just call an attribute. So underscore underscore attribute, 2 parentheses, packed. And we'll do the same thing for block headers. And what will happen is that when we compile this and compile any code that uses this, it will assign, or it will create these structs in contiguous memory blocks. So it won't define them based on the word size, it will just define them based on the size of the fields. So it won't use this method, it will use just contiguous memory blocks. So it will be more efficient with memory, and then when I send it to someone across a network, they know exactly what they're getting because it's predictable. Okay? So this solution comes from Camel Coder, also OJ002 on our Discord. So if you're enjoying the stream, feel free to join us on Discord. We continue talking about these things afterwards. And actually, during the week, I'm usually working on the project that I'm going to be presenting in the live stream. So if you want to join me on that, this is a great place for you to do that. And also, we have general discussions about other things as well. So feel free to join us over on Discord. There is a link to that in the description. Okay, I need to check my battery. Make sure we're still at 50%. Excellent. Okay. So we have this attribute, and this is going to make it so that everything it's not dependent on your machine, so that if I send this block to you, then you know what it looks like, and if you send it to me, then I know what it's going to look like, and the architecture of our machine isn't going to interfere with that. Okay? And also, we talked about how we are going to create these, but I think it would be useful for us to create a constructor for a block so that we can really demonstrate it and you can really understand what's going on here. So where is this? So I should change the name of this file, but I'm actually not sure that I'm going to be keeping this file, and that's something we're going to be talking about in a little bit. But let's just create it here. So, well, first we'll need to define it up here. This is going to have to return a block pointer, and you'll see why when we actually create it. Usually my constructors return an actual object, but this time we are going to return a pointer to an object. And you could probably guess that that's because we are going to have to allocate it on the heap rather than the stack, and you'll understand why momentarily. We're going to call this block constructor. And this is going to take a void pointer to data, and it is going to take the unsigned long size of that data, and you see, we would usually put, this is probably actually an inappropriate time to make this block constructor because all of the things that we would want to do that give purpose to having these fields, we're not going to do right now. So it's actually a bad time to make this block constructor, but I just want to make sure that everyone understands how this is actually being done. So we are just going to pass in the unsigned long size, and we'll just put some dummy data in to those fields. Just stick with me on this. You'll understand why that's necessary. Okay, so we're going to define it in the .c file. And what we're going to do is first allocate space. So we need to create the block headers, and we need space for both those block headers and the actual data. So first we are going to create a struct block pointer block, we'll set it equal to, I'll need the standard library for this. We'll allocate the size of struct block headers plus size. So that is the size of our headers plus the size of our data. Now, our block object has 1 extra byte, remember, for data, but we're just using that as the memory address for the first field in our actual data. So we don't need to worry about that. We are just going to pretend it's not there while we're allocating things. We can assume that there's at least 1 byte in our data. You're not going to send an empty block. Okay, so we're going to allocate that. And, well, that is the size of the thing we are allocating, and we are going to allocate, or that is the number of things we are allocating, and this is the size of that. So let's actually reverse this. These functions are a bit odd. So what this is basically saying is that I am going to allocate 1 object of this size. And what I was writing there was that I am going to allocate this many objects of 1 byte. So I was going to allocate that many bytes. And either way, you get the same result. And I don't know if there is a more efficient way. Maybe if you know, you can tell me in the chat. But yeah, it seems a bit strange to me that you would specify one or the other. But maybe there is a reason for it. Perhaps one of you can tell me. Anyway, so we're going to allocate the space for it. And then we are going to cast it as a block, basically. And then we can access all of these fields. So for first, we're going to need, I'm going to pull up the actual block headers there so that we can see these fields. And it's actually not better. It's hard to see. Okay. So first, we need to fill in the previous and the by. The only reason is that these are both unsigned character arrays of size 64, and so we'll fill those in with a for loop. So for int I equals 0, I is less than 4, I plus, and we will say block headers dot previous I equals A, and block sorry about that, headers dot by I equals B. Okay. And let's see. So we'll have a timestamp. So, or well, let's set the nunts. So block headers nunts equals 100,000, doesn't matter. And then block headers dot size equals size plus block headers. You get the point, basically. Now that we have created this space in memory and we cast that space as a pointer to a block object, the block object contains first a block headers object. So we can just access those fields directly and set them. And I just want to point out, by the way, that our size field is the size of the data that is being added and the headers together. Okay, so it's the complete size of the entire block. Okay, so we can just access these fields directly and set them to be whatever we want. And the most important one is going to be this. We're going to need the string library for this, because that gives us access to the Mem Copy function. Okay, So memcopy allows us to copy data from one place to another, basically 1 byte at a time. And so the destination for this is going to be block data. And remember that block data, we actually just want the memory address of block data. That is just the pointer to the first byte before the rest of our block, the rest of what we allocated up here. So we allocated enough space for whatever data we want, plus the size of those headers. And our data field is just the pointer, the address of, well, I should say the address of that field is a pointer to the first memory address of the rest of our data, the first memory address of the rest of our data, the first day of the rest of our lives. Anyway, we are going to copy the data from data, and it will be of size. Now, whenever we want the data, whatever it is, we just access that data field by memory address. And it could be a string, it could be an integer, it could be a movie, it could be an image, it could be anything. And so long as we know the size of it and where this data field begins, we can just access it. Okay, so that's how we would create one of these. And I'm actually, well, after this we would turn block. And there's a bit of a problem here because the user's going to have to remember to free this memory space once they receive the block. So since we have used calloc here and allocated memory on the heap, the user is going to need to free it. But like I said, we are not actually going to keep this constructor. I was just demonstrating it so that you could see how things were going to work. And you'll have to excuse me for a second because with the beautiful weather comes pollen, and I need to sneeze. All right, sorry about that. It's probably for the best that I have allergies. Otherwise, I would just be outside all day today. So anyway, get settled back in. So yeah, I'm not actually going to keep this. So it's okay that I am not, that this is working the way it is. Okay, so we use our attribute packed in order to define this as being of a particular format in memory regardless of architecture. Then we just simply allocate enough space for both this and whatever data we want, and we use this field in the block to access the first byte of however much data we have allocated. Okay, so that is basically how this is working. And I want to tie this back into GitHub for a moment. So you remember I was telling you about creating these issues. So over here, we have a project, blockchain. That one's for later, actually. Here it is. So I've created this problem, and I believe I have mentioned in here. Yes, this comes from Camel Coder as well. So he was the one that was telling me about these attributes and showing me how to create these things. He was, in fact, informing me of this problem in the first place. So a lot of credit goes to him here, but I wasn't actually able to open him up on or connect him to this for some reason. I don't know how to do that. So I have to learn more about GitHub myself. But anyway, I create an issue here to say this is a problem and to suggest some code for a solution. So you can come here onto libeom issues and then contiguous memory, and you can read a basic summary of what the problem is. And I happen to had already gotten the solution from Camel Coder, so I wrote the solution in with the problem. But in the future, I won't necessarily do that. I will be doing these or creating these problems live as I am having them. So then someone who has a solution can come and leave a comment here offering advice or solutions. We can organize what needs to be done with milestones, and we can connect this with projects. So as a matter of fact, I'm going to connect this to the blockchain project, and we will see it automatically gets added to the to-do list. So if I go to projects and then blockchain over here in to-do, we have contiguous memory problem, but we actually have already solved the contiguous memory problem. So what I would have done is moved it over here once Camel Coder had given me that solution. And now that I have implemented it, and we can do a quick test on it. So, well, we've already implemented it, so let's move it over here to review in progress, and let's run a quick test on it as well. So what I want to do is actually a lot simpler than what we have been doing with all these client functions and server functions and all that. I'm going to remove the attribute packed from each of them. And in our main function down here, we're just going to printf %ul %l size of struct block headers size of struct block lu. I never memorized those. Anyway, so if we run this, it'll just tell us the size. And this is the unpacked size. So, wow, we can see that the block headers actually takes up 1,681, but somehow the block only takes up 176. I'm unconvinced. LUL. So, see that? Let's try that again. 168 and 176. So we can see that our our padded data structures are 168 and 176 bytes. And what's interesting is that our block actually only adds 1 byte to the end of our headers, but actually it ends up adding how many? 8? Yeah, it ends up adding 8 bytes. So apparently that one byte was at the very end of a word, and that ends up adding a whole new section to this. So if we stop this, and now we are going to go back to this, let's give our attribute back. Okay, so currently our score is 168, 176. Afterwards, it is 164, 165. So we can see that the sizes are being preserved. It has passed the test. We know that this is working. So we can move review in progress to reviewer approved. And now I am going to go ahead and add it to the repository or commit it. So we're in libom, so I can say git add dot. So what do we do? Punctuation. Now I will push it. Ooh. Remote rejected. What happened here? Let's try it with, yeah, I spelled it wrong. Hold on. that one worked. There we go. Okay. So it should be available to you now. So if we look at our code, look at the working branch, networking, protocols, blockheaders.h, there's our attribute. Okay. So we know that that has been completed. So did we have any milestones? We did have a milestone, so we can look at that. Let's see. And I am just going to say edit milestone, close milestone. There we go. Done. And blockchain. Done. Great. So that's how it will basically work. If you see a new issue, feel free to open up an issue. You can tie it to a project if you like. And if you see any, or if you see a solution to an issue that's presented, you can offer your solution in the comments of those issues. So GitHub is going to be a really great way for us to kind of collaborate over the internet. And I especially want to thank once again Camel Coder for starting us off in that process. He has submitted a lot of code to me, mostly through Discord and some through GitHub, and I really appreciate that. That has been a lot of fun being able to actually work with people on code. And also, I want to give a shout out to the Koskiv, and Valtteri is his name on GitHub. I'm not going to be able to find his account right now, but he has also offered code and contributed a lot to the project, so I want to extend my gratitude there as well. I really appreciated that. So, one more thing that I want to talk about before we move on to a whole new topic, and that is what I am going to call the buffer problem. The buffer problem. Okay, so the buffer problem. And that has to do with this. So we are going to close out all of this. And let's look at our server function here. Okay, so we accept the client. We create a void pointer to hold the requests that they send, and then we read that request into this buffer that we have created. Now, blocks on the network can be of variable size. We don't know what is being sent in them. It could be a 5-character text message, or it could be a 10-gigabyte video. So how do we create a buffer for that? Basically, the only option, as far as I've seen so far, is to create a buffer that is the maximum block that you are willing to accept. I believe Valtteri actually had a solution to this, so maybe he can remind me of what his solution was there, although I think I may still have it. But this is the problem that I want to focus in on now. We have to allocate this space here, and this is too much space. We can't just allocate this every single time that we receive a message. We can't afford it because, first of all, it's presumably as big as we could possibly store, and so we can't do 2 at the same time, of course. And so it's just a really inelegant solution. And the problem is we don't know how much we need to store until we have actually read in the data and cast this as a block, because at that point we can access the block headers dot size, and then we can see exactly how size this whole thing is. So maybe there's a way that we can accept the client and then read only the size of block headers, get the full size, and then perform another read on the same client for the rest of the block for exactly the size that they are sending. But that is the problem that we are going to try and address this week. So over here on GitHub, where is this? I believe this might actually be in the sketchbook. Over here, the buffer problem. Okay. So I demonstrate the problem here. And basically the solution that we are looking for is one that will allow the server to accept a block from a client and not have to allocate all of the space that it possibly can. And so this week we will be looking on this. So I hope you would join me in the discussion in these comments and help me find the actual answer. We'll be putting in some milestones, and this is going to be tied. There's a bit of a difference between the way projects are organized here on GitHub and how they are organized, or excuse me, there's a difference between how my projects are organized in the sketchbook versus libeom. So let's talk about that very quickly. In the sketchbook, my projects match the branches. So here, if we look at the code, each branch is just a different experiment I'm running. I preface them with the language that I am using. So sometimes I use Python, sometimes I use C, and I then follow that with whatever, just some descriptor of what I am experimenting with. And then over here in the projects, project will have a name that corresponds with one of those branches. And basically it opens when I open problems in this when I have questions. Okay, whereas in libeom, I open problems when there are improvements to be made or questions that I have. So I'm not actually trying to improve the sketchbook. Okay, this is just an experimental platform, me trying to learn things. Whereas libeom, I'm actually trying to improve it. Okay, so the issues and projects here are more for improvements, and the sketchbook is more for questions and answers. Okay, and you can open up issues in both of these as well. So if you have questions about my code over on the sketchbook, feel free to ask. You can open up an issue and ask a question about one of my projects. You can even have a project, you can even refer to the particular branch that I'm working on so that you can specify what code you're asking about. So the projects and issues are used a little bit differently between these two repositories, but basically the point of this is to say that we have one for this week, and it is the buffer problem. So feel free to join me over here as we talk about that and try to solve the buffer problem. Okay, so now I'm going to take a 2-minute break, get some water, because the pollen, I can feel it in my throat. I need to check with the chat real quick. Oh, I have been missing Mr. Gamer. Okay, Mr. Gamer, I will fix it, bro. Great, I hope you will. I think we could use, something called valgrind to check for memory leaks. Is it a buffer overflow? I don't think it's the best way. I know what to do. I'm sorry, I must have missed this. I was looking at something else on this screen during that time, so I'm not quite sure. Let's take a look at the Discord. Let's see what you sent. Yeah, right here. Thought that was you. It's really confusing, actually, having people with different names on different platforms and trying to keep track of, yep, there's our message. We're going to have to lose the face cam here in a minute. But okay, these are, you're talking about two separate problems here. I see. Okay, we will talk about that later. So I am going to take a brief break here, grab some water, clear my throat, and then we are going to come back and we are going to talk about the future. So I have some plans, and as I said at the beginning of this video, we are at a point in libeom where we are about to kind of splinter off, and we are about to try something. Well, the project we're working on is no longer going to be appropriate in the library, and we're going to have to make an executable of our own. And this is going to be the kind of final product of what we're making here. And we need to have a discussion about what that is going to look like. So stay tuned. I'm going to grab a glass of water, and I will be back shortly. And I need to unplug things. That. All right, I'll be back. Okay. Welcome back, ladies and gentlemen. So, at this point, we need to have a little discussion. Okay, so we need to talk about how the library is beginning to branch off. Okay, so we can see here in the test file that I've created, I'm going to make this a little smaller. I've created a server function, I've created a client function, and I have demoed how this peer-to-peer function is, or constructor and object are working. And here I have this example of blocks. Now, it's rather questionable how useful these blocks are in other projects. Are they only useful in this blockchain project, or is there some other application where I might want access to this? I can conceivably see, well, given that I'm not even planning to use these fields in the actual project, it doesn't really make sense that I would want this object later. I would probably want something else. Really, if anything, what I want from this is to remember that I can have this packed attribute. There are also other attributes. I'll make a video on those different attributes in the future, but there are also other attributes that we can use. And what I want from this file is to remember this, not any of these fields or this data structure. So I'll probably end up deleting this file from the library. And that leads to the question of, how are we going to actually build the blockchain application that each of us is going to run on our servers or our machines to interact with the network? And that is not going to be libeom. That is going to be its own thing. And so we need to talk about what that thing is going to look like. There are a few different models we could go for. And I want to think, what is the best way to visualize this? So, okay. We're going to come over here. And we'll make a flowchart. Okay, so the first question is, how integrated do we want this thing to be? So if we imagine, I need to find the right thing here. Devices, that'll work. So let's say that, oh, this is rough. Sorry. Okay, great. This is what we need. This is our server, okay? This is our hardware. And the first question is, how integrated do we want this application to be? How all-encompassing should this application be? So if you are running this application on your machine, does it take 100% of the machine's resources, or can you run other things in addition to just that one program? So if you think of the web hosting application, Apache, you can run Apache and a Samba server and a Minecraft server all on the same machine. So do we want to make something like that, or do we want to force people to make dedicated machines? If we want dedicated machines, then we're looking at something that's a little bit more like editing the Linux kernel than building a standalone application. So we probably want to build a standalone application instead. So on this machine, we are going to be running at least our application. Okay, so what is that going to consist of? Well, the idea of a peer-to-peer network is everyone is simultaneously a client. Let's find something to represent a client. That's a good one. We'll probably want that later. Let's just remember that. So we need a client. Where's our client? So let's use a little smartphone for a client. iPhone. Great. Okay, so we have a client function, and we have a server function. So let's find a little database.
killing me. It's just giving me a bunch of the same thing. Use this. Okay, so it has its server function. So this is the part of the application that goes out and gets blocks from other nodes. And this is the part that responds to nodes and accesses its own chain or its own local chain. So the question now is, how integrated do we want these two components? We could make it so that if you are installing something on your main machine, that you could install either blockchain client or blockchain server, and you decide that you want one or the other. And in that case, the client would need to be able to do a lot of things on its own, and we might need to recycle a lot of code from the server. Another option is to make them a little bit more integrated. So we could have one application. Everybody downloads exactly the same application, and that application has both client and server capabilities. And in fact, the client utilizes the server. So if I want to look at my local blocks, whatever blocks I have created, then my client is actually just going to ping the loop back and use the server to look for those blocks. And if my client application or client functionality wants to search the entire network for something, it will actually send that request to its server. So it will use the server as its access point for everything. So basically, everybody is a server, and everybody just has this small application here that can do client things. So that is a more integrated way of looking at it. Now, the other question is, what exactly are we trying to send on this chain? Like, what are we sending on this network? And the point of me making these blocks in such a way that we could put anything in them, we can put any kind of data, be it images, movies, or text, or whatever, is that I don't want to be the one who decides what's on the network. I want to make a platform for other applications, much the same way HTTP is sort of a platform for websites. So I want to make it really easy to develop a application that utilizes this blockchain. So what I want to make this blockchain do may be different from what you want to make this blockchain do. So quite simply, you will create and install an application on your server, on your blockchain server, that does whatever you're trying to do. So maybe it sends text messages, or maybe it does videos. And then you would basically use that application to utilize the blockchain in whatever way you see fit. And we could all be running different server applications to provide different services to the network. And that's the basic idea. So both this server and client functionality will have the ability to have apps installed on them. I don't know if there's a good way I can demonstrate this. So if I just bring that out, what if I make it curved or rounded? No, that's not very good. Anyway, both of these, what we are going to build is essentially the thing that allows you to install an application, utilize the blockchain in a particular way. So we could do either this integrated or separated function. And we, of course, have this on GitHub. So if we go back to libeom and we look at projects and blockchain, you'll see we have this product design issue open. I have it up in to do. Now that I have brought it to all of your attention, I'm going to move it over to in progress, because now the discussion is open. And I'm hoping that you will join me over here on GitHub. Again, the link is in the description. I would like for us to have a discussion about what we want from this application. What do we want? A single or multiple applications that allow you to kind of just get the components you want, or do we want a single standalone simple application? So join me over here, and this is just a discussion. So nobody's assigned to it. We are just going to talk about it. I have voiced my opinion here. So my view is that the integrated version is better. It's a little bit more elegant. If we think of this one portal into the blockchain, be it your local chain or a foreign chain or anything else, it's all done through this one portal. And the client functionality is just a way of basically accessing the loopback of your server. And so even if you are running a client application that, or a machine that is not itself providing any services over a server, so let's say your ports are closed, then your client would still utilize this server to query its own local storage or query those other nodes. So in any situation, this seems to fit pretty well. So I voiced my opinion there, but I would like to hear your opinion as well. So please join me on GitHub and leave a comment below there and tell me what you think about this problem. Should we have a single application? Should we have multiple applications? And what exactly are you envisioning this as being? Okay. Now, let me give you kind of a demonstration of what I would like this to look like, so I can kind of make it clear what I'm thinking of here. And I'm going to do that here on my terminal. So let's go to my desktop. Let's make it a little bigger for you. And I'm going to, well, I'm going to create this text file. And so we can see there's that text file there. And I'm going to use a program called SHASUM. And I can say -A512 and then test.txt. And it's going to output the SHA-512 hash of this file. Okay, and I just bring this up to show you kind of what I envision the interface being like. So you could type in the name of the program. So let's say we have chain. And then you would specify that you want to query the chain. Query. And then you would put in some filter or whatever you want. And you would have this sort of command line interface where you could just type in a command and get your output. Or perhaps this is a better example. We could say blockchain-create, and then I could say test.txt, and it would take test.txt, and it would output a block file. And that block file, I could then say blockchain-share test.block, and it would then share that block with all of the nodes on the network. So that is kind of my vision of what we are going to make, and the question is just what functionalities would we offer there? So I like the idea of there being a command line interface to it, but I am open to suggestions there. Also, another question is that if we think about my Python, for example, so I have Python 3 here, so let's touch example.py, edit it, we'll just say print. Okay, so with Python, I can use the command python3 and then the argument example.py to specify use the Python 3 interpreter to execute that code, and it will execute that code. Or I could say, I think I can do this, Python 3 print no, I can't. Okay, that's fair enough. I can't do it like that. But I can also use just Python 3, and it opens up this command line interface. So now I can say print hello world, and it will do that, and I can say x equals 5. that. And perhaps our product, instead of saying blockchain dash query or whatever, you could just say blockchain, and that would open up a shell interface that would let you type in multiple commands. And we can kind of go based on that. But that's just my thinking of what this is going to be. And then the other question is, how are we going to install applications on it? So let's, oh, you say no, not like that? What are you thinking, Mr. Gamer? There's a bit of a lag between you typing a message. Oh, I see. Python 3-C print. There we go. Great. Thank you. I appreciate that. So, good, Mr. Gamer there. Anyway, so how are we going to... You did make me lose my train of thought there. I'm sorry. I have some notes I'm checking on the side. Yeah, installing applications. So what is that? What do I mean by that? So I don't think, do I have installation of Apache anywhere? I don't think so. Not on anything running at the moment. Shame. So if we look at over here. So if you've ever used the web hosting software Apache, you are familiar with the concept of a virtual host. And a virtual host is basically a service that you are offering. So you can offer multiple websites from one server. And these websites can be vastly different. You could host something like this. You could host a Wikipedia style website. You could host a YouTube style website. And in theory, you could host a blockchain. So what I am thinking is that installing applications on our platform would be like creating a virtual host in Apache. Essentially, we would have basically a folder somewhere, and you would have some executable file, probably written in C. Maybe we can make it portable to Python. And you would just click and drag that into a certain folder. You would specify something in a configuration file, and then that would launch the service. And then when other nodes come and they ping your node, then it will return things based on that service. But we can specify more about that later. So basically what I'm thinking is that we are going to be trying to create, through this blockchain, a platform for creating other blockchain applications. And these can really be anything. I think one of the easiest things to make will be a chat network. So I think I will demonstrate that functionality first and kind of just make that a core feature of the network. But essentially, everybody would be able to decide for themselves what they wanted to do with the blockchain, and then they would be able to provide services in association with that, if that is clear. Okay? So this is a bit of a short one, but I think that is going to about cover it for this week, because really the whole point of this today was to kind of show you guys more about GitHub and how we are organizing the project and what we're working on. And I feel at this point we've covered everything I was hoping to cover here. We understand how I am opening issues in GitHub and how I'm organizing things based on projects. I've shown you how libeom is differs from the sketchbook, and how my blockchain project, or our blockchain project, is kind of splintering from libeom. So you know what? While we're here, let's go ahead and create a new repository. And while I do this, why don't we go ahead and transition to a little bit of Q&A. So I see we have some viewers here. Some guys are active in the chat. So if you have any questions for me, feel free to specify them in the chat. And while we are doing that, I'm going to create a new project on GitHub and create a new local and remote repository. And I'll kind of teach you how I do that as I go. But this will be for the actual blockchain application. So you have any questions, throw them in the chat. Otherwise, I'm going to be teaching about setting up a project for the first time. So what I'm going to do is first go to my terminal, and I want to create my remote repositories first. Now, I have a local remote repository. So I have a server to my left here on video. I don't know how that mirrors for you guys. And also, I'm not even showing you my face at the moment, so there's nothing to see there. But what I'm going to do is go to that server, and I'm going to use SSH. SSH allows me to connect to a server and basically take control of it from this computer. And then I need to specify the IP address. Now, on my Mac, I have specified host names for different machines on my network. So I can actually say SSH library.local, where I store all of my remote repositories. Now, I use an encrypted SSH connection, or I use public and private keys. And so I have to type in a password there. And you can also set it up so you don't need a password, but I use the most secure method possible because I do this over the internet. So that's always the best option there. So if we look, I have in my go to cd/repositories, and then what are we going to call this? B. So we're in there. So let me show you how I actually organize this. I create folders for every letter of the alphabet, and then I just put projects based on their name in each of these folders. So we can say LSL, and in the L directory, I have libeom, or LSS, there's the sketchbook. So these are where I store all of my remote repositories. Right now, I need to go into CDB, because we are going to make a directory called blockchain. We'll go into blockchain, and I'm going to say git init bear. So that creates an empty Git repository on my server. And now I can use this as a remote repository as somewhere kind of safe to store all of my code. So it's not only here on my local machine. Okay, so now I can exit my SSH connection, turn to the desktop. I'm going to go back to my documents. Okay, let's close out of libeom. We'll open Xcode, and I'm going to create a new project. Now, I need to decide what project I'm going to, or what platform I'm going to make this for. And this is going to be for Mac OS. It's going to be a command line tool written in C. And I'm going to call this blockchain. I do want it to create a Git repository on my Mac. So I'm going to just create that in documents. And now I actually forgot to do something. So I need to go back to this. So there's a bit of a difference in standards in creating Git repositories. So if I go to my blockchain repository list, and then I'm going to do cat over head, I'm going to display the contents of head, we can see that it calls the main branch master. And Apple calls it main, and that will cause problems later. So I'm going to nano head, and I am just going to change this to main. So now the main branch is main. Okay, now we're back to the Mac. And the first thing I'm going to do before anything else is just add my remote repository. Oh, and I need a GitHub for this as well. I'm going to create a new, where do I even do that? New. I'm not going to put a description on it just yet. I'm just going to create the repository. Okay. A little worried I'm showing you guys something that you shouldn't be seeing here, but I don't think I am. So I'll just copy that. And now I can say cd blockchain get remote add origin, and this is library dot // and then I'd put the path to that bare repository that I just created. So /repositories /b/blockchain, and I can say get status, okay, get push origin main. So I am going to, using get, I'm going to push to my origin remote repository, that is this one, and the main branch. So I'm going to push that. I need my key. There we go. And now get, oh, I need to add the remote repository for GitHub. Get remote add public. And then there's that SSH ID that GitHub provides. Go. And we are in business. So here's our blockchain. Okay. So we have created this, and I need to do a few things to kind of clean things up. But really what I want is to kind of connect this to the library, because we are going to be using the library here. And, well, actually, that is going to be a little bit more of a challenge than I was actually thinking, because the library is currently only in my documents folder. And over here in test, if we, I'm just going to kind of sneak in here and open main.c. If we look at how I reference it, I use a relative path. And that's because I don't have it in here. So let me show you. This is actually kind of interesting. Problem I run into in a while. So let's go to this folder. If I go to /user, not /bin, go to user. So user, local, and include. Okay, so here are all the header files for C. And, well, some of them anyway. So they're kind of all over the place, unfortunately. There's not one place where all of them exist. But here's where a lot of them are. Now, if I were to move libeom into here, then I could reference things like this with the greater than less than sign rather than quotes. And I also wouldn't have to use the relative path. I would just specify to use this particular .h file. And I don't currently have it installed, so I actually don't want to do this just yet, because remember, this is kind of a final product, and I want to build this in a way that someone who has actually installed all of these things would have their system set up. And they are not going to have their system set up so that what they're installing is in the same directory as the library. So we're going to need to do this in a slightly different way. And what that leads me to is yet another project here on GitHub. So if we hop back onto libeom, go to issues, well, projects, blockchain. Nope, not there. Where is it? Documentation and cleanup. So this is something I need to do. Since this blockchain project is sort of splintering off into its own repository, I need to go through the library as it stands right now. Where is it? Did I close it? I think I closed it. I need to go through this library and clean it up so that I can merge the working branch with main. Purpose being, I want kind of a stable release. And the result of that stable release is going to be a .a file, or a static library. And this static library I can import basically into the folder of this project. and then I can use that to build it. And I can just copy all of the header files into my folder that I showed you a second ago. And that will allow me to basically create a make file for it. And it will be really easy for people to build this for whatever machine that they are running it on. Okay? So I hope that is relatively clear. I'm not seeing any questions in the chat. So remember, if you have any questions for me, feel free to ask. We're just kind of setting up the project at this point. So there are some initial files I want to create, and they're kind of ubiquitous to any project. So like a README file. So let's go ahead and make that. And a markdown file. Yep, README. They know. Okay. I'll fill out the details in all of these later. And I'll need a make file. Do they have something for this? I think it's just empty. And then there's one additional one that I need for this, and it has to do with Xcode specifically. So it's this. These headers, they drive me nuts. I don't know why they make it so difficult to actually change them. But let's open go package contents. It's this. Yeah, you need this file right here. I'm just going to copy that. And let's go back. Okay, so that should work. Let's delete this file. And let's see if our new headers have arrived. So basically all I was trying to do there was create the new headers, header comment. Main.c. There we go. Oh, but they're wrong. Okay. That's a shame. So Xcode makes it really not easy to have something other than the default headers. So I really like the IDE, but that is an unfortunate aspect of working with it. So I need to edit this. At least it's an interesting, someone out there that uses Xcode is going to be very glad that I shared this with them. So maybe one of you three is that person. Say, so text, edit, new document. Okay. Let's see. What are we going to call it? Blockchain. I like it with a lowercase b. A little more casual, you know. I don't need to save that. So, okay, file name, blockchain, and open source blockchain. We need a license in here at some point, and I'm thinking that the GPL version 2, whatever they use for Linux, what do they use for Linux? Yeah. Now, I don't know the specifics of these, and fortunately, I'm not going to put any code in this just yet. But eventually we're going to need to change this so that it has a license in it as well. Or maybe we can just put that in a README. But anyway, this is the header that we want in all of our documents. And let's close that. Just delete it. Open that. And now I can paste it there. Save. Delete this. Great. Okay, so our header files are good to go. And we have a make file, we have a readme. What else would we need in here? Let's reorganize these. I would probably want to clone. See, here's the question. When someone installs this, what happens? So, actually, I don't know what happens. So that is a question. Let's open up a new question on GitHub here. So, where do we want this? Should we go ahead and do it in blockchain? Does that make sense? So, I don't really want to do that just yet. But basically, what does an installation process look like? Is it a process where like a make file runs and it basically runs all these commands on your system to actually install everything? Is that what's happening? Or is it some custom script that runs? What is it? So I don't really know what an installation is like. So I don't know where my libeom should be expected to be. And I also don't know, I don't know what's typical here. Should I include all of the libeom files that they need within this? That way you can just have a single download and it doesn't need to presume that you have libeom installed. Maybe we need to do it like that. I don't really know. And I'm going to just open that up as an issue. I'm not going to make any projects, but open an issue. And we'll call it I'll flesh this out a little bit more later, but basically I'm just going to say how am I going to? Okay, you know what? A bit tricky here, actually. I'm trying to do this on the fly in a stream. I might create an issue later. So here's what I'm going to do. I'm going to say, I'm going to just put connecting to libeom. I'll flesh out this content later, and I wonder if it's just even optional. Okay, I can flesh this out later if I need to, but now we can all see it. And as always, feel free to jump in and comment there. I'd really appreciate your input on this. So where should my library files and headers be in relation to this application? Should I basically make a clone of libeom here in blockchain so that I can just access them directly and not assume that anybody is actually installing that library? So that would make things pretty easy. Or I could assume that they haven't installed. I don't really know. So give me some feedback there. I'd like to hear your thoughts on that. So we've got our README, we've got our makefile, and I need a gitignore for one particular file. What file is it? Okay, there's a file in Xcode. Is it this? So let me show you this. Let's this, the interface state. Anytime you do anything with the interface in Xcode, the user interface state updates. Now, this is really useful because if I open Xcode, it will open exactly where I left off. So it's really nice. But when using it with Git, it's really a pain because it updates every single time. So your Git, you need to update it. So you need to add it or restore it, and it's really kind of a pain. So I'm going to add it to my git ignore. So nano, well, right, is that how you spell it? I didn't remember if it was capitalized at all. Okay. And, you know, I forget the syntax for it as well. There's a syntax here, isn't there? Can I just put this? I don't really remember. If I need to change it later, I'll change it. So those are the basic things that we have. So we'll just add all of this. Okay, just making sure we're all good to go. Great. Okay, so here is where we are going to begin developing the project. So we'll have our main function in here. Let's go ahead and paste that in for now. Oh, it's gone. Okay, well, so long. And here we are going to basically run the function. This is what every one of us is going to, well, I mean, assuming you want to, this is what we're all going to install on our machines in order to connect to the network and participate. So this is, as far as my view goes, remember we have a discussion open on GitHub to talk about what the actual implementation of this is going to be. Let's see, this is going to be in product design. So hop over here if you want to participate in that discussion. And anyway, so as far as I'm viewing it right now, this is where we are going to basically load in a configuration file that will set some parameters for our client and server functionalities. It will initialize those client and server functionalities, and then it will allow us to sort of interface with it in some way, either through command line arguments or some interactive shell, whichever way we decide to do it. But it's all going to take place in here. And it's going to draw from the library. As we are building on this, we are going to continue trying to add things to the library, but it's sort of independent from the library at this point, and we need to begin thinking of it in that way. And maybe the best way to do that is to begin by creating our block objects. So I don't quite know how we want to organize all of these directories yet. Let's just go ahead and create it right here. And we will revise that in the future. We do want to create that header. And so we'll end up deleting the one in libeom in favor of this one. And we don't need that, but we do want to define a struct. It's going to be block headers. And here we are still undecided on what these fields need to be. There are only two that I know of for sure, and that is going to be the unsigned character array called previous hash. That's going to be 64 bytes. And then we are also going to have an unsigned long for the nonce. And that's how you are going to hash this object. And then we know we need the attribute. Whoops, not has attribute, but packed. So this is going to be packed. And we will add more fields to this as we learn what we need. So again, I don't know what exactly needs to be in here at the moment. So we are just going to kind of leave it bare. And then we are going to have a struct block, not block headers. And this is going to have block headers and an unsigned character data. Also has the packed attribute. Oh, and there we go. And let's create our constructor. And now we're not going to fill it with dummy data. We're going to have the user actually pass in the real data. And we're going to assume that they have all of this information ahead of time. Is that a reasonable thing to assume? Perhaps not. We'll find out. So, we'll pass in a previous character and unsigned long nonce and void pointer to the data we want and the size. That's another thing we're going to need. Go. We're absolutely going to need the size of the object in the headers. Okay, so we'll pass in the size. And let's define what this does. So let's copy that function over just so we don't. Okay, so first we're going to allocate space on the heap. So we'll need the standard library. So struct block pointer block equals calc. The amount, the size that we want, the number of them we want one object of size of struct block headers plus size. And then we are going to do what exactly? So for int I equals 0, I is less than 64, plus. So block headers dot previous hash I equals previous hash I. Great. So that's just going to copy what's in here over to here. Okay, and then we can say block headers dot nonce block headers dot size equals size of struct block headers plus size, because remember, the header fields are going to include the size of the entire block. So the header field's size field stores the entire block's size, not the data's size. Okay, so we're going to add those together, store that there, and then we can copy over the data from here into this. So what we're going to do is get the string library. Okay, and we'll call Mem Copy. So its destination is going to be block, well, the address of data. And the source is going to be data the user has passed. Size is going to be the size that they have told us. Now, this is most likely not going to be, well, we'll return the block. Now, again, remember, we need to remember to free this once we are done. And Mr. Gamer, I think you said something in the chat about this, but maybe we can talk more about that later. Anyway, this is probably not going to be the implementation we want, because most likely what we'll do is have the user pass in the data they want and the previous hash, and the rest of it will probably be decided in the back end. So it's probably not going to be up to the user what the nonce is. So we'll probably, like, in the process of constructing a block, we will probably calculate the nonce for the first time. So now, then again, we also may be reading it in from a file. So we may need multiple constructors for this, but for now, this will do. So this gives us our initial objects and kind of gets us ready to start using them. Again, we still have a bit of a question. We'll include the block here. Probably need to change that path in the future. That's okay. And let's have our main function. And how do the args for that go again? So int argc and constant character pointer argv. Yeah. Great. Okay. So I think we're going to leave it here for now. I need to do a little more experimenting with things and speak with some people on GitHub about how we're actually going to design this before I actually make any more progress. So this is a bit of a different stream. It was kind of more a business meeting. We were talking about how we are organizing things on GitHub and a few of the problems that we have tackled over the week and some things like that. I showed you a little bit of how certain things were implemented. We learned about this attribute pact, and we've begun splintering off this blockchain project from the library project. So we're having some different things going on here now. So I'm not seeing any questions popping up in the chat. That's fine. If you are enjoying these streams, I hope you will join me over on Discord. We continue the discussions there, and we continue working on these things throughout the week. So if you are enjoying this sort of thing, then please join us over here and on GitHub. And if you do stop over at GitHub, feel free to follow me, star the libraries, and whatever things you feel are necessary over there. Let's see, we'll probably be doing another stream next week where we will pick up where we are leaving off here, and we'll just do a little bit of a shorter stream this week. So be on the lookout for some content this week. I'm going to try and summarize some of the things and talk about more of these attributes and maybe talk more about how blockchains work in general in shorter, regular videos throughout the week. So keep your eye out for that. And as always, thank you for joining me. I really enjoy doing this with you guys and really appreciate everyone who participates. So thank you for being here, and I will see you in the future. Toodaloo.